Welcome back to part 2 of our video of section 9.1 on polar coordinates. We're going to finish filling in this chart. So what I've given you on example 2 is the polar coordinate -3 pi over 3 right here. So let's find out where that is. So remember, do the theta first. Pi over 3 is 60 degrees. So we come up here to 60 degrees, but then it says a radius of -3. So I need to come back down 1, 2, 3. I'm right here. Okay? If I'm right there, we need to now find all these different ways to name that point. So, for example, if I want to just keep this a +3 but have a negative theta, which is this point right here, then that would be, this would be a positive 240, so this would be a negative, and we have to stick in radians, don't we? So this needs to be negative 2 pi over 3, because this is in radians. So this would be a +3, but negative 2 pi over 3. And I alluded to it earlier, if I go all the way around here, that is at 4 pi over 3 with a +3. Okay, let's go the other direction. I now want R to be negative again, which means I'm really playing up here at the 60 degree, at the pi over 3 line, and then I'm going to back up 3. So if I have a negative radius, that's going to be a -3, but I need to figure out what this would be. Well, if I'm up here, I know that that's at the pi over 3, but I need a negative theta. So I have to go all the way around, and that would be -5 pi over 3. Now if I want to spin around the circle, right, I'm going to have a radius of 3, but I'm going to go all the way around, and then I'm going to add another 240 degrees, or another 4 pi over 3. So I'm going to have essentially 2 pi plus that 4 pi over 3, but that means that I need to have a common denominator. So that would really make this over 3, that would make that 6 pi. So that would give me 10 pi over 3 would be that radian value. All right, let's try another one. If I'm giving you the theta is pi over 6, we're here at 30 degrees, and we're going to come out a radius of 2. So that puts me 1, 2 right here. Okay. If I have a negative theta, if I come back the opposite direction, I go the negative way, that is 11, this is at pi over 6. So that would be at 11 pi over 6, right? +2 at a -11 pi over 6. Now we want the R to be negative, which means I'm really playing, instead of pi over 6 here, I'm really playing over here in quadrant 3 at 7 pi over 6. So when I do that, I'm going to have -2 at 7 pi over 6, right? I would come all the way around here to 7 pi over 6 and then back up 2. Now we want them both to be negative. So you want a negative radius, and then you want a negative theta. So you're playing over here at the -210, and then you want to back up. So you're coming this way and then backing up. So this is a -5 pi over 6. Right, because 5 pi over 6 is in quadrant 2, but if I come the negative direction, it's here in quadrant 3. Now, then I want to spin around. Remember, we're here. So if we start here at the polar axis, and we go all the way around, and then we come back up another pi over 6, that's going to be 2 pi plus another pi over 6. All right, that would be 12 pi over 6, so I'm going to be at 13 pi over 6. That's 13 pi over 6. So this will be part of your assignment. Will be give me 3 other ways to name this point. And this is a very good way to remember. You're going the positive direction, you're going the negative direction. You're backing up for the radius, you're going forward. Okay? Now let's talk about some simple equations. These are very, very simple in that we're going to do some later that aren't so simple. But right now, these are the simple equations. And I would like you to write down that if you have an equation that has a plus or minus r equals some number, that is simply a circle with that radius of that value k. And the center of the circle is always at the pole or at the origin here. If you have the simple equation theta equals a number, then that is simply a line of all the points that make up that angle that you're given. And that may be a radian value, maybe a degree value, but it will be all of the points through the circle at that angle. For example, let's do some of these, and I'm going to get some highlighters. So I'm going to pause it for a minute while I get those. Okay, we're good to go. All right, first I'd like you to graph the radius of 2. This is a radius of 2, so that is simply a circle with radius 2. Here we go. So I'm going to underline this so that you know that that's the one I'm doing. I'm going to come out, there's radius 1, here is radius 2. And that is simply all you need to do. Okay? If we graph one that is of a radius -4, let's do that one in blue. Well, if I have a -4, it's still going to be, if I start here at the polar axis and I go to the negative direction, right, I still have the circle with a radius of 4, but you can write the equation with the positive or the negative. All right, let's try this one in green. We're going to graph the line of theta equals pi over 4. That is simply at pi over 4, 45 degrees, you're going to graph that line. I usually start from the center and go out, and then I start from the center and go out. That way I make sure I get the whole thing. You need to remember to have it going in both directions. One more. If I want to graph the line theta equals 5 pi over 6, 5 pi over 6 is in quadrant 2, so I'm going to come over to 5 pi over 6, draw that line, and then simply extend it in the other direction. Okay, those are easy equations. We're going to do some that are a little trickier later. All right, so that is your first lesson in polar coordinates, and I look forward to going on to doing section 9-2. I think you will enjoy that. We get to draw some pretty pictures and do some more involved equations. Thank you. I'll see you in class.